So let's take a look at these. This first one, what do we have to do first? So for this first one, guys, what do we got to do first?
Plus 7.
Add 7. Very good. Do that. There we go. Add 7. Get rid of that. Have to add 7 over there to keep that scale balanced. So 3x equals 36. Then what? Divide by 3. X equals 12. What do we have to do over here? Subtract 18. So 3 minus 18 is a negative 15. And then divide by negative 3. You get 5 equals y, or y equals 5. Those look familiar? How many of you have experience solving equations like that? Okay. Basically what's going on is you have a variable equals a number, and that's where all equations start. The key to working with them, of course, falls in that symbol right there, the equal sign. What does the equal sign mean? Okay. It's tough to define without using the term equals, isn't it, or equality? And that is, what's on one side is equal to what's on the other. Or what's on one side has exactly the same value as what's on the other side. And you can think of that as being a balanced scale. The balance is around that equal sign. What's on one side has the same value, has the same weight as what's on the other. All equations start out in this form as a variable equals a number. And they're built up from there. So to build it up, one of the things we could do is we could add to both sides. So I might add 7 to the x. So now I have x plus 7. Now I said add 7 to both sides because if we do something to one side, the scale is going to tip unless I do exactly the same thing to the other side. So adding 7 over here, 4 plus 7 is 11. So I've now built a more complicated equation, but it is still this equation. Most of the time we're not asked to build equations, we're asked to solve an equation. And we're asked to solve an equation. What it's really asking us to do is to take this equation apart and get back to this point here. Well, this equation was built by adding 7. How are we going to take it apart? Well, the opposite of adding 7 is subtracting 7. So you subtract 7 both sides, you get back to x equals 4. So when you're asked to solve, that's what it's asking you, is to take it apart and get it back to that base equation. Now we built that equation so we knew how it was built, so we knew how to take it apart. The key is looking at an equation and figuring out how it is built. So if we have something like 5x equals 20, or 20 equals 5x, the way we figure out how it was built is we find the equal sign, then we identify which side of the equation has the variable on it. Then we ask ourselves, what's keeping that variable from being alone? Right now it's the 5. What operation was used to attach the 5 to the x? It was multiplied. So to take it apart, we're going to divide. Divide by 5, that's gone, we have x there. Divide by 5 over here, 20 divided by 5 is 4. So x equals 4. Well, those are pretty simple equations. We're going to run into things more complicated like 3x minus 2 equals 25. Same process applies there. We find the equal sign and we identify where the variable is. Then we ask ourselves what's keeping the variable from being by itself, from being alone. It's the 3 and the 2. The 3 is multiplied and the 2 is subtracted. So to figure out how this was built, we have to ask ourselves what was done to x. Now, according to order of operations, now I'm not talking about solving the equation, just order of operations. What would you do first? Would you multiply or would you subtract? You would multiply first. You multiply before you subtract. So when this equation was built, x was multiplied by 3 first. Then the 2 was subtracted from it. Now, let's say you put something together, whether you're assembling a part or maybe a toy or a piece of furniture or whatever. You've just finished. You've just put on that last piece. When you go to take it apart, what's going to be the first piece you take off? It's that last piece you put on, right? You're going to take it apart in backwards order of the way you put it together. So the last piece that was put on here was subtracting 2. So that's going to be the first piece we remove to take it apart. You're going to add 2. So that's gone. We have 3x equals 25 plus 2 is 27. Now we can take off the 3. It's multiplied, so we're going to divide it. So x equals 9. Now, if you're not sure if you did it correctly, you can always go back to the original equation and replace the variable with the value that it equals. If x equals 9, I can replace x with 9 in there. So instead of 3x, I can write 3 times 9 minus 2 equals 25. And then double check. Does this come out to the same value over here as I have over here? Well, 3 times 9 is 27, minus 2 is 25. I do have the same value on both sides. I can run into this. So here I find my equal sign and identify which side has the variable on it. And I find the variable appears twice. Both times, however, on the same side of the equation. So if I think about the balanced scale thing here, can I just push those together and make one big pile? Would that change the balance of my scale? No, it shouldn't. They're on the same side. So I can just push them together and it won't change the scale, the rest of the scale. So we've got 7x and negative 2x make 5x. I can just combine them. And I still have the positive 3 or plus 3 equals 48. From there, what do I have to do to solve it? Subtract 3. 5x equals 45. And then divide by 5. X equals 9. Again, I could go back up here and I could replace x with 9 this time. 7x becomes 7 times 9. Plus 3 minus 2x becomes 2 times 9. We have to check to see if that comes out to 48. Well, 7 times x is 63. Plus 3 minus 2 times 9 is 18. 63 plus 3 is 66. Minus 18 is 48. So I do get the same value on both sides. What do you think? Not too horrible? Well, what if, come on. We have this. I find my equal sign, and I go to identify where the variable is, and I find the variable appears twice, and it's once on each side. I can't just push them together anymore because they're not on the same side of the scale. They're separated. So I have to get rid of one of them. So what I'm going to get rid of is I'm going to get rid of the easier one to get rid of will always be the smaller one. So the smaller one here is going to be the 2x. So I'm going to get rid of it. In math, how we get rid of something is by adding or subtracting it. That's a positive 2x, so I'm going to subtract 2x to get rid of it. Leaves me with just 14 over there. But now, because that balanced scale idea, if I subtract 2x from one side, I do have to take it away from the other side. The only place I can take it away over here is from the 5x. So 5x minus 2x is 3x. Can't forget the negative 7 there. Now I solved this just like any other equation. This looks like a lot of the others we've done. First step now is going to be adding 7. So 3x equals 21, and then divide by 3. So x equals 7.
You couldn't just move like terms to the same side that way?
Well, that's basically what I was doing. I can't put the 5x over. You're thinking you'll move it to the other side, but then you may make it negative, right? And that's what some people have been taught is you're moving it over and making it, switching its sign. What's really happening is you're eliminating it. By subtracting the 2x here, I am putting a 2x or negative 2x over here. I'm putting the opposite over here. This is just what's actually happening. What a lot of people are taught that shortcut is you move it over to the other side and change the sign. Yeah, it's just, this is what's actually happening. This is the formal way of doing it. When you start getting deep into math and number theory, you start to realize a lot of what you're taught is a shortcut. Yeah, it is the same thing. It would give you the exact same result. I'm going to have you guys try some of these here quick. I know it's a little early to be giving homework, but I'm going to have you get started on the homework. Then I'm going to add some more stuff to this as the next couple of hours goes along. Partly because my voice is really fading fast right now. So, on page 368, exercise 14-5, page 370, exercise 14-6. These first couple are extremely simple solving equations. Feel free to just do a few and then skip on. Page 373, exercise 14-7, page 375 through 376, exercise 14-8, page 378, exercise 14-9, and only one more, I promise, page 380. Exercise 14-10. These last four are a little more difficult. Make sure you do some of those. There are a couple of examples that we'll go through again in a little bit of time here. I'll throw some more stuff at you. But have you get started on those for now, and we'll look at more examples here in a little bit. I'm going to throw ones like this on you quick. What's different about this one? Parentheses. And whenever you see parentheses, it should scream at you, do something here first. And the first thing we should look for is if there's anything we can do inside those parentheses. For this set of parentheses, is there anything we can do inside of them? No. 2x minus 7, there's really nothing we can combine there. So the second thing we have to look for is if there's anything that needs to be done to the parentheses. And in this case, they're being multiplied by 5. So we do 5 times 2x, which is 10x. 5 times negative 7, negative 35, equals 25. Then we've got to add the 35. So 10x equals 60, and divide by 10. So as you can see, the goal is to get pretty much all the equations we're working with, get them into that form, so it's just add or subtract and then divide. So how about this one? Tell me what to do.
21x plus 7.
Okay, yeah, 7 times 3x is 21x. And 7 times 1 is plus 7. Okay, we will subtract 7. So 105 equals 21x. And then divide by 21. So 5 equals x. As always, I can go back and put that 5 back in there. And 3 times 5 is 15, plus 1 is 16, times 7 is 112. We get the same value on both sides. So don't forget, if you're unsure, you can always do that. Put the value back in, and you better get the same value on both sides equal sign. Any questions? Okay, well, what about something like this? What would I do with this? Start with the parentheses. I'm going to work left to right. Now, here's my equal sign. I can actually simplify one side of the equal sign all at one time and then go to the other side. I don't have to work back and forth. It's only when I start to solve it that I have to deal with both sides at the same time. So on the left side, I have this first set of parentheses. Anything to do inside of them? No. But I do have to multiply by the 8. So 8 times 5x is 40x. 8 times negative 3? Negative 24. Next set of parentheses. Anything to do inside of them? Nope. What do I have to do to them? Not times 2, but times negative 2. Negative 2 times 3x is negative 6x. Negative 2 times 1, negative 2. And I still have that negative 5 at the end there. Now I can combine. I've got 40x and negative 6x make 34x. Negative 24, negative 2, and negative 5 make negative 31. So 34x minus 31 is what I get on the left side. Now I go over to the right side. See that set of parentheses? There's nothing to do in them, but there is something to do to them. It's times negative 3. So I'm going to put in my 2x up here first. Negative 3 times 4x. Negative 12x. Negative 3 times 5, negative 5 is a positive 15 plus 7. What's next? 2x and negative 12x makes negative 10x. 15 and 7 make positive 22. What do I do then? I've got a very... Sure, there's an x on each side. So I'm going to get rid of the smaller one. The negative 10x is the smaller one, so to get rid of it, I'm going to add 10x. So that cancels out to be 0. Leaves me with 22 over here. I have to add 10x to the other side. So 34 plus 10 is 44x. So 44x minus 31 equals 22. Then what? Add 31. 44x equals 53, and then, excuse me, I'll divide by 44. X equals 1 and 9/44. What do you think? Okay, I'll let you get back to the pages for now. A few minutes, we'll take a break, and then we'll start up again at 9:30, or 8:30, sorry.